All right, I just wanted to record this walkthrough because I've gotten a few messages from people who sort of feel a little bit lost when we made the switch to object-oriented programming. And this is the middle of like a 4-week project, right? Like each week we're adding new features to the same project. So I don't want people to fall behind. I acknowledge this is not a normal semester, so a lot of the normal interactions we would have, we're not having. And so I don't mind a little bit more hand-holding, besides which I think I'm going to switch this particular assignment up for next semester anyway. So regardless, the idea here is that we're trying to create a class that we will use as a template to create objects later. So a class just sort of has blank slots, right? Variables. We're doing it generically. And then later on, we can actually create individual restaurant objects, right? For something like a DoorDash app. I've called mine Dinner Dash. But it doesn't really matter. We're using it to model something in the world. Later on, if you get into sort of software architecture, you may hear of something called a model view controller architecture. Model objects tend to represent things in your application, whether that's a social network where you've got friends, or if it's, a DoorDash thing where you have restaurants and menu items and orders and things like that. So here we're trying to design a restaurant. We need to create a restaurant class. So let's go ahead and right-click on our project folder. Ooh, hi there. And then we'll choose a new C++ class. Now you can create these files separately if you want. I just do it all in one. And also if you're coming from another class, because I know that other instructors will teach it slightly different ways, this is sort of the normal way. This is what you would see in industry for the most part, separate header files. But there are some people who put everything together. If you're coming from another class on campus where they happen to have done that and you want to do it that way, it's not terribly offensive. I'm just showing people sort of the way you're most likely going to see it in the field. So choose a new C++ class. It's going to create the header and CPP files for us both. Our class will be called restaurant. Now, by convention, you usually name the files after the class that they contain. Sometimes you might want to import a particular class into your project, but you don't want to, do all 3 different classes. So having them separated out allows people to import what they need and not what they don't. Add to targets, sure. We need to have that checked. Create header only, we don't want to do, so we'll just say okay. And here we go. Now, there's a whole bunch of little things that C-Line is doing for us. One, there's a risk in C++ of import, like I create something, right? And let's say I import, file foo or something like that, foo.h. And then somebody imports my project into their project, but then they also import foo.h, right? Or include, I should say, in this language. Well, then C++ is not really smart enough to know that they shouldn't include that twice. And so that code base may actually get imported twice, and then you're going to have conflicts because you've got 2 versions of everything. And so one way you can get around that is by putting in sort of include guards, is what they're often called. You'll see some here. So if not defined, these are preprocessor directives. So if not defined this, define this as whatever I put in between these, and then I have an end if. That is the traditional way that is actually specified by the C++ language. You can also just get rid of this and do one single hashtag. I forgot what it is, but regardless, if you see something different because you're using a different IDE, there's a couple different ways of doing it, and just that's okay. It also created the little stub for us here for our class restaurant. So now all we need to do is just fill it up with stuff. It's got the assignment over here on the side, so it says we need to create the following private member variables. Now, why are we creating them as private? First off, I'm typing on an elevated keyboard here. I don't actually have to declare these as private. In a class, all members are private by default. You have to specify if you want them public. This is not true for structs, by the way. As a programmer, I think of structs as a simple way of just lumping pieces of data together. But whenever it comes to functionality, I always think classes. But in actuality, in C++, the way these are implemented, classes and structs are exactly the same. They're implemented in the exact same way. The only difference between a class and a struct is that all members of a struct are public by default, and all members of a class are private by default. So, but the reason that we want our variables to be private is that we don't want, we're implementing something called data hiding. It's a strategy when creating something. And the idea behind data hiding is that if I give you direct access to my variables, you can do anything you want. I can't really change anything. Like if you can just perform operations on variables, like I get no say in how this is supposed to work. Now for a restaurant, that doesn't really matter so much, but we will use an example as we're going through. For something like, I think in the lecture I mentioned a bank account, right? The balance of an account, you can't just add or subtract to that when you deposit or withdraw, right? Accounting actually is more complex. It has to have an offsetting transaction to another account. There's also little things like if you happen to deposit more than $10,000 in cash, a report has to be made to the FBI to check for potential money laundering. These are things that maybe not every programmer in your company knows. And so if they have direct access to your variables, they could just say, oh, well, if I'm just doing this thing, I just have to change the balance. Whereas you can say, no, I'm keeping these members private, and I'm going to give you public functions that you can use that are attached to my objects, but those functions will allow me to have lines of code, go through some processes, make sure there's another account. In fact, maybe you have to give me that other account along with the amount, right? To do a transaction, you're going to give me 2 accounts and an amount. And so anyway, it gives you more control. And we'll talk a little bit about this when it comes to rating these restaurants, because you're going to create a getter for the rating, but you're not going to create a setter. You can't go to a restaurant and no programmer can just change the rating of a restaurant. In order to do that, like you have to go through the rate function, which does whatever it needs to do. So the members that we need to create here in private are a string for the, not Java, lowercase s, a string for the name of the restaurant. Oh, and here we've got some red. That's just because I have not done anything up here. So let's see here, include. So now actually in the header file, I'm probably not going to use IOStream. I'm not going to do any sort of input and output. We're not implementing these functions in the header. In the header, we're just defining the class. So I actually don't need IOStream, but I do obviously need string. And then I can choose whether or not I want to put the STD everywhere. So using namespace standard will allow me not have to do that. Okay, so string for name. And then it says I need a string for the address. I need a string for the genre. Actually, in my Java class, we came up with a better word, category. But you know what I mean? Like genre, you think books, you think albums. But category, the thing at the top of DoorDash, when you choose chicken or healthy or Mexican, right? It's the category of the restaurant. In reality, maybe you have an array with different tags of categories, but every restaurant will have one category in our very simple app. And then we need 2 more functions, the number of ratings and the rating itself. The reason for this is if you're going to Yelp or something, right? You see restaurants, and if it has 3, ratings that are really high, that doesn't mean a whole lot. If it has like 500 ratings that are really high, well, that probably means something. So the number of ratings actually does matter to people, but also those 2 will allow us to keep track of the current rating of the restaurant without having to actually save every individual's score, because we can always weight the next score by just taking the average and multiplying it by the current number of ratings. So that means that we need an integer for num of ratings, and we need a double for the rating itself. The idea being, and you could possibly change this if you wanted to, the number, well, I should have. For this point, it just makes sense. The rating should have a double. There should be a decimal point there, right? You can't have a half of a rating, right? Like if you rate something, you're going to increase the number of ratings by 1. That's going to be an integer. You can't have a half, right? But the actual rating itself might have decimal places. In fact, it makes more sense, especially if you were to do this on a 5. I think the assignment has you do it on a 10. That's arbitrary. But if you did a 5-star setup sort of a thing, there's a huge difference between 3 and 3.5 stars, right? Because you only have 5 stars to play with. So anyway, we've got some now private members. And so now we can do our public section. In our public section, we're going to need to create the getters and setters for all of those, well, not for all of them, for the first 3, and then just a getter for rating. Now, in the lecture video, I think I show you how to do this, but if you're using C-Line, which is kind of what I recommended, we'll start with doing the first ones manually. So the getter for name is just going to be a function that returns the name of the restaurant. So it is going to return a string. It is going to be called getName by convention. So getters start with get, setters start with set, and then followed by the name of the variable, and then make sure you do it camel case. GetName does not require anything. Right? It doesn't require anything because an object will already have the name of the restaurant inside of it. That's one of the fields inside of that object. So you don't need to send anything to getName. You just call getName on the object, and it will return the name to you. The setter, it kind of works the opposite. Setter doesn't give you back anything. You're sending a name to change the name of a restaurant. So it's going to change the name of the restaurant. So the thing that it needs is a string that you send it. You can do this stylistically. This works perfectly fine. At this point, all the compiler needs to know is, does it take a string, 2 strings, which would be string, comma, string. It just needs to know the type and sort of the order of the parameters. You don't have to give the parameters names yet. I kind of like to, though. So I'm going to say name, which, yes, is the same as this, but it will know that this is a parameter and not this, and we'll tell how to differentiate them later. So there we go. I've created my public getters and setters. Now, instead of continuing on, I'm actually going to go ahead and implement those 2 right now. So I'm in restaurant.h. That's my header file. That's just going to have the declaration for my restaurant. If you look at a header file, you'll be able to tell what's included in an object and all the different methods you can use on that object. If I were being better about putting in good comments, you would know what those methods do, although getters and setters are pretty straightforward. The implementation file is where we're actually going to implement this. And you'll see that C-Line has already included restaurant.h, which makes sense. In order to do any of this, we have to have access to the header file. You have to include restaurant.h in this file. But now we need to actually define those first 2 functions or methods. Methods are just functions that belong to a class in general. Although in C++ textbooks, they generally call these member functions rather than methods, but it all means the same thing. Just, you know how like fandoms get, you get, your C++ fans and your Java fans, and like Java fans call member variables fields, but other people may call it something different. It's just, yeah, you know what I'm saying. So here we need to implement that function. What I do is, the reason I put this here is that when I implement functions, I often just copy, go over to the implementation file, and paste. Now this is not right, but it's a good start. So for getName, for instance, there's 2 things I need to do before I can start implementing this. One, I have to say that this getName belongs to the restaurant class. I'm not creating a new getName function, right? And then I need to replace that semicolon with a set of curly braces, and now I can write my code for whatever I want getName to do. Now getName is going to be super simple because it's just return name. Right now, there is no conflict. I don't have a more local definition of name. And so you can see this turned purple. And yep, there it goes. Finally turned purple. And so the name here is also purple. So you can kind of tell that that's the name it's referring to. There is no more local definition of name, so it goes back to the member variable name. However, we want to be a little bit more precise. Well, in fact, we'll be more precise on this one because we need to. So here, same thing. I need to say that as a member of the restaurant class. And then get rid of that curly brace, replace it with, get rid of the semicolon, replace it with some curly braces, and now I can do what this is supposed to do. This is just supposed to change the member variable name to whatever it is you sent me. Well, whatever you send me as an argument to this function is going to be captured by that parameter name. You're going to essentially assign the parameter a value when you call the function, and you send it a string. That's the name of the restaurant. And so here, I just have to change that to the parameter. So name equals name. Now you can probably see what the issue is here. This name is not the same as this name. It's because there's now a more local definition. So all three of these just refer to the parameter, and this function does absolutely nothing. There's a couple different ways you could solve it. One is you don't call that by, something else. And then now the parameter is in. I'm taking in and assigning that value to name. That's one way to do it. My preferred way to do it is this parameter, because it can sometimes pop up in little code hints when you're actually using the objects. It's nice to have this be something you can read and understand. So this is a name I'm sending. And then for this, to get it to refer to the name that's inside the object, I have a reference to the object that you called this set name on. So whenever you call any of these functions on an object, you're going to use dot notation, right? So it'll be like new restaurant dot set name, and then you send it the string, the habit or something like that. So that thing that you called it on, new restaurant, is an object. And so I have a reference to that object, and it's with the keyword this. So this always refers to the object on the left side of the dot when you actually call set name. Right now we're just defining set name, but later on when you call it, it'll be there. And so because this is I shouldn't say reference, this is C++, a pointer, that means I have two ways I could do this. One is I could, as we sort of know, dereference the pointer and then use dot notation. Now, why in the heck did I have to make that so complicated? It's because dot has a higher order of operations. In other words, you do it first before star. And so instead of dereferencing this and then accessing that object's name field, what you'll end up doing is trying to dereference the field at this dot name. This doesn't exist. So it sort of messes everything up. The other way to do that is that C++ came up with a shortcut so that you don't have to dereference and then use dot notation. Instead, you can use the arrow operator. And so basically you use dot notation whenever the thing on the left is an object, and you use arrow whenever the thing on the left is a pointer. So this arrow name means the name inside of the object that you called set name on. And then we're just going to assign it the value of name, which is the parameter that received whatever you sent when you called this function. So this is a great way to implement a getter and setter. C++ or C Lion has a slightly better way, or not a better way, just a faster way, which is just go over here, right click, choose generate, and choose getters and setters. Now it doesn't have name on here anymore because it knows that I've already implemented the getter and setter for name. So instead, address, category, I don't want to do these bottom two. I'm just going to do address and category. And then I will say OK. And it will auto-generate all the code for me. I'll start with the header because that'll hopefully make a little bit more sense. So here I've got get address, get category, set category. Now you notice they're actually doing something a little bit more, which is that these things don't actually return a string object. They return a string alias. In other words, I'm just giving you sort of a reference to the string that already exists rather than trying to copy something. That saves you a few clock cycles, and so it's generally considered the better way to go. And then by making everything constant, you're ensuring that you're not going to change the original string. So they're doing it in a slightly more professional way. I prefer my manual way for learning. And then eventually, once you get more comfortable with aliases and constants, it's like, oh, okay, I get it. This function is just trying to save some clock cycles by not having to copy stuff. It's just returning an alias to the original string. But that being said, those two things are done. Now that's only with strings, by the way. For everything else, they're going to look really similar. So here I'm actually just going to, because you also have to implement a getter for the rating, but not a setter. C++ can, or C-line can handle that too. Generate, instead of choosing getter and setter, just choose the getter for rating. You don't need a number of ratings ever. And okay. And then this returns, or get rating will return a double, and it just returns the rating. And I'm double spacing is not a bad idea. I'm just getting rid of the double spacing so you can see more of the code on the screen at any one time. All right, so we've done all of our private member variables. We've done our public getters and setters. Now it says we need to implement it says three additional functions, but I already did the getter for rating, which is actually the second one. So number 2 is already done. We just have to do 1 and 3 still. So 1 and 3 are going to be the rate method and the display method. So the rate method will return nothing. We'll call it rate. And the thing that it takes is the new score you're going to give the restaurant, right? The new rating. So let's call that, I think I say to do an int. I do say to do an int. And call it score. You can call it whatever you want, really. The naming of things is not something that I care as much about. It's really the functionality of it. So with rate, I'm going to maybe call this new rating. It's like it's the rating that you're giving it in that moment. And I'm saying it's an int. It could be a double if you wanted to allow people to give like a 5.5. There's no reason you couldn't do that. So the choice to make this an int is arbitrary. If you had a website or something, I guess, and it had like buttons for 1 to 10, then you'd have to do ints. But if it was a slidey sort of a thing, you could do doubles. That'd be fine. But regardless, this is good enough. The other thing we need is also going to return nothing. We're going to call it display. And display is going to take nothing as well. So rate and display, the purpose of rating is to rate a restaurant and, change its rating. And then the purpose of display is just to display a restaurant on the screen. So since those do not have implementations, copy and paste. And now we just have to implement these two. I'm leaving my getters and setters on top. I'll probably put constructors above them, but we're not there yet. And so then here is the rate function, new rating. So this is going to be a member of the restaurant class. And we'll do a curly braces, and so now we're set to go. So for rating, there's a couple different ways you can do this. And I think I mentioned them in a announcement. One is you could just have rating, just keep a running total of all of the different scores that people give the restaurant. And then whenever you wanted to get the rating, you should divide by the number of ratings, and that will give you the average rating, which, by the way, you would probably do right here, right? You would just say if a rating is actually a running total of ratings, just divide it by number of ratings, and now whenever somebody calls that function, they're going to get the right rating. The problem is the word rating sort of implies that that actually is going to be the 6.7 or whatever that restaurant earned. And so I prefer to keep that sort of true. So mathematically, if I kept everybody's individual scores, right, and then we divided by the total, like that would give us a rating. But I could also just say, well, hey, if I already have the average, when, you know, the 100th person rates this restaurant, I could just weight it by taking the average, right? Like all these different numbers are the same thing as the average of those numbers multiplied by the number of ratings. So it kind of goes both ways. So if I did that, then I could properly weight so that, you know, if you're the second person to rate a restaurant, your rating means a lot. You can change the rating of a restaurant several points in just, you know, one rating. But if you're the 1,000th person to rate a restaurant, you really can't move it much at all, right? You're being weighted along with the other 1,000, or I guess other 999 ratings. So what are we going to do? We are going to do some fancy math. Not really fancy math, but we're going to say that rating is going to be equal to, or assign rating the value of, take the current rating, the average, multiply it by the num of ratings, right? So this would effectively give us that running total of ratings numbers. Then we're going to add to that the new rating, the one that you're currently giving it. Now I'm going to put all of that in parentheses. And the reason I'm going to put all that in parentheses, actually, I could get rid of these parentheses, right? According to order of operations, multiplication will happen before addition. But I'm now about to divide this, and I don't want the division to happen before that addition. And so then on this side, it's going to be we're going to divide by the num of ratings plus 1, because now you are the new rater, right? So if there were 99 ratings before, they averaged 5, then that's 5 times 99 plus your new one, divided by 99 of the old ratings plus your new 1. Done. And that will accurately keep the rating. The other thing I'm going to need to do, though, is take the num of ratings and add to it. By the way, if you want to get really slick and you care about prefix and postfix, so when you put the plus plus at the end, that means use this variable in the expression, and then once you're done evaluating the expression and you've already done whatever you're going to do, add 1 to it at the end. When you do plus plus in the prefix position, that means add 1 to this number and then calculate it as part of the expression. But you've already added 1 to the number, meaning that I'm going to keep this in parentheses just because it's helpful. Oh, I didn't need to do that. Oh, that's fine. Plus plus num of ratings will simultaneously add 1 to the number of ratings, but also it adds 1, which incorporates your new rating, right? So it permanently adds the 1 and assigns that value back to num of ratings before calculating that in the expression. And so that should work. Now, display is actually just basically input, output, arts, and crafts. All right, so display is a member of the restaurant class. And now we just need to do our input, outputs, arts, and crafts. We can see out a bunch of stuff. Sometimes you can return stuff as a string. Other times you just print it to this is just going to print it to the screen for us. By the way, I see that there, which means that I need to do a few more includes. So we're going to include IOStream, because I'm going to definitely need that. I would like to include string, because every once in a while you need something from there. And we'll use our using namespace standard, so I don't have to put the STD everywhere. Now, that'll eventually correct itself. For the restaurant, let's just keep it simple. Name, colon, space. Next thing I'm going to send is the actual name of the restaurant. You can put this arrow name if you want to. I know that I don't need to, so I won't. And then an end line would be good. Because I'm at the end of my line when it gets printed, I'm actually going to drop down to the next bit here. And then address, colon, space. Put the address, end line. category, we did name, address, category, and so then the last thing I'm going to print out is the rating. For this one, I'm going to print out the rating, and then I'm going to continue on, do a space, open parentheses, the num of ratings. I don't have to do this. I don't know if it says to do it in the assignment, but why not? And then we'll do a new line that way. Yeah, that'll work out just fine. So the idea here is that the num of ratings will be in parentheses after the rating itself. So you can see, oh, I've got a 4.5 with 3 people reviewing it, sort of thing. All right. So now I should be able to get this set up. Now there's going to be one small issue, and several of you have probably run into it, which is when you're done with the first one, you're going to have the problem that the way C++ works, when you create something, like, I create a restaurant, it doesn't initialize these variables to anything. We're about to do the thing that will initialize those, but we haven't done it yet. So right now, these all end up being sort of whatever happened to be in memory at the time it was allocated, which means that the num of ratings and the rating's not going to be such a big deal because you multiply it by something in the very first time you do it, right? Like if I go back over to the implementation, the very first time you run the rating, or you call rate, you multiply the rating by the num of ratings. If the num of ratings is 0, then that makes this whole thing 0, and then we set the rating, and at that point it now has a value. The real linchpin here is that num of ratings. So this came along a little bit later. We have a better way of doing it with a constructor, but for right now, this is going to at least make it work. Create a default value for your num of ratings in the restaurant class. And that'll allow us to test this real quick. So inside of main, I'm just going to do a little bit of work. So the first thing I need to do is I'm going to go ahead and include the string library, and then I'm going to include restaurant.h. So now I can actually use those restaurant objects, and then I'll use that using namespace standard thing. And try not typing so bad with my keyboard elevated. And so now I can create restaurant objects. So let's do that. Restaurant A. Honestly, in C++, this is a perfectly fine way of creating a restaurant. Now, we don't have a constructor. We'll talk about what a constructor is later, but right now, like, we get the default constructor for free, if that's just given to us. It doesn't do anything. I already told you, it doesn't even initialize variables to 0 for us, but it creates the objects, allocates the memory, and returns that sort of reference to it. So here, restaurant A, we're calling a default constructor, something that takes no parameters. Soon we'll have some custom ones to use. But right now, restaurant A, we have a restaurant object, which means that now I can start calling methods like a.setName would be a good one because it doesn't have a name at this point. And so we'll call this one Eureka Burger. And we'll do a.setName, or sorry, I already did set the name, set address, and we'll make this 1234 Palm Avenue. I have no idea what that is. I guess North Palm Avenue. We can decide whether or not we want to do any more address. I don't really care. Set category. I have a red squiggle, so I'm wondering what I've done, why it doesn't like that one. Set category, and this is obviously going to be a burger place. Oh, how about I actually put semicolons in, because I'm not programming in Python for this demo. I'm programming in C++. The negatives of teaching multiple languages at the same time. All right, so I have created a restaurant. I've given it a name, an address, a category. I have not given it a rating because that's not how we do it, right? The way that you rate a restaurant is by, well, rating the restaurant. That's how you give it a rating. So a.rate, I happen to like Eureka Burger, so I'm going to give it a 9. Somebody else, they didn't think so much of it. They gave it a 6. Somebody else, kind of split the difference. And somebody else, it's their favorite restaurant. All right, so now we've got some ratings. Only thing left to do is a.display. And so you can see how I'm actually calling these functions on an object. That restaurant object we created that here I just gave it the variable name A, but right, we're putting data into it, we're rating it, we're using it as we would expect. And if I run this, it's going to take a while to build, which is normal, especially the first time you do it. Here we go. So name, Eureka Burger. Here's the address. Category is burger. The rating is an 8.25 with 4 ratings. First part of the assignment, done. And now for stage 2 of the project. We need to add a couple more features. This won't take too long, but just a few more features using constructors and static members. We could do this in either way. I'm going to say let's do constructors first. So I'm going to create a constructor. I will list it here above the getters and setters. And basically a constructor is a special type of function. It's a member function of a class. 2 things that are unique about it when you're defining it. 1, it does not have a return value. Strictly speaking, this is not true. It does return something. It returns a reference to the actual object, but it creates the object, and we just don't list a return. We don't say that it returns anything. The return sort of happens by the system. But then it also has to have the exact same name as the class. So we get no choice as what to name this. It's going to be called a restaurant. And there are a couple different ways of doing it. So I'm going to create one that actually takes everything. So you give it all the information for a restaurant, and that will create it. So here we're going to do a string for name, a string for address, and a string for category. And actually that will be it, because that is the most that I want you, oh, sorry, not Java. That's the most that I want you to be able to assign a restaurant when it's created. Everything else should start at, the number of ratings and ratings should start at 0. So this is just basically saying, hey, when you create a restaurant, I'll let you go ahead and send me 3 things, and I will take those 3 things and automatically fill in the restaurant with that information. And we'll create a little method to do it. It'll also allow us to do some assigning, so you can take care of that. If I go to main CPP right now, you're going to see that I have a little red squiggle here. So something happened. I just wanted to tell you because it may come up. So the second you create a constructor, here I haven't even implemented it yet, I just declared it. But as soon as you declare a constructor, you lose your default constructor. That's the constructor that allows you to create a restaurant without sending information. Basically, once you create a constructor, C++ assumes, oh, then you have a very specific way how you want us to create these objects. So we're going to get rid of the default constructor. We're not going to give you anything. We're going to let you decide for yourself what you want your constructors to be. If you don't create constructors at all, we'll give you the default for free that doesn't do anything. But since you have opinions now, it's all on you. I feel like this is an argument you would have a teenager or something, but regardless, it's your compiler. So restaurant, 3 strings, bam, which means we should probably also create a restaurant that has none, but I'm going to implement this one first. And so up here at the top of my implementation file, I'm going to, you know what, we've double spaced all the other functions. Let's stay consistent. So I'm going to create that restaurant. Now, again, this looks weird. At least once you get used to writing functions, and you're probably not used to it yet, But like, as you get used to it, this is going to feel weird because you don't put a return type. There is no return type. All these other ones have something hanging off the front. This has nothing hanging off the front. We're just going to say this is a member of the restaurant class. It's called restaurant, and it takes a string for name, a string for address, and a string for category. Curly braces to actually do it. Oh, there we go. Thought I misspelled something again. There we go. So I've been given 3 strings, specifically in the order name, address, category. So that means I want to say this arrow name equals name. This arrow address equals address. This arrow category equals category. Ooh. See, I got so bored, my typing got even worse. So those were just setting the fields with the values that you set. Easy. While we're here, num of ratings equals 0, and rating equals 0. We haven't done anything yet, so they should start somewhere. They should start at 0. And by the way, had I printed out a restaurant before I actually rated it, then my rating would have been a nonsensical number because I hadn't yet overridden it to 0. All right, so this is our constructor. Now we need to create a second constructor. It mentions, I think I'm doing these out of order. It's fine. I started with the constructors rather than the static members. So the first one was to implement a custom constructor that takes all 3 strings and initializes those values. Done. Another one is override the default constructor, the one that has no parameters, to increment the restaurant count. Now, the reason why this one is important is because even if you never plan to use it, right, and we've already used it once, but even if you never plan to use it, other library, especially collection classes like vectors, they will use the default constructor to determine how much memory to allocate when creating the vector, or whatever collection it happens to be. So it's really helpful to have a default constructor in C++, to have the one that has no parameters, just for those purposes. And so otherwise you may be working on something later on and figure out like, wait, why is this vector not working? Well, it's because you no longer have a default constructor. There's a couple different ways we can do this. I think you probably know where I'm going with this at this point, but I'm going to, boom, right-click here, choose Generate, because of course C-line will also generate. I mean, you saw how bored I was when I was writing the constructor. Like, you can write a constructor. In this case, by the way, you sort of like have one selected no matter what. These are the parameters you're going to want to use and initialize in this particular constructor. And you can even do different versions, right? You could do a version, I'm going to hold down the command key, that just uses name and category. So I say command because I'm on a Mac, but if you're on a PC, control to get a non-contiguous selection, or you can hold down shift to get a contiguous selection where it selects everything in between. Regardless, you can choose what you want for the parameters, but they have a select none button down here for the default constructor that generates none. So if I click on this, boom, it automatically implements in the wrong location, however. Cut. I want my constructors up here these days. Since it gives you a little stub for the default constructor, and in the header, it creates a little default constructor. So you at least get a stub. It doesn't do anything, however, so we're still going to need to do some work. It's not quite like the getters and setters. Actually, even the getters and setters, oftentimes you want to put some work into it, right? Like you might have a number, and so in the getters and setters, you might put in some guards to say, hey, if they try to, change this to a value that's greater than the possible values, then don't allow it. Something like that. So these, you can actually make these more custom. So here's my default constructor. Basically, I can just do copy. So in other languages, you have a way of calling a different constructor from one constructor. That sort of makes this the designated constructor because it has the most values I want you to be able to initialize. And then I can just call this version but send different amounts, and so that allows me to keep all of my functionality in one place. I don't know why I'm telling you this, because C++ doesn't allow that. So unfortunately, we need to duplicate ourselves, and that's not good. I generally don't want to duplicate my code. But here I don't have a name, so I'm going to set that to the default. See, C-line I think was trying to help me and not doing a very good job of it. This one here, I'm going to put empty strings for all of these. Num of ratings is 0, ratings is 0, exactly what I want. So there we go. We've got 2 constructors now, one that does nothing, one that initializes everything to default values, one that does this. That also means I can get rid of this thing, which might be fine. I don't know in sort of modern C++ if this is now more common for like default field values, but I like to have everything in the constructor. So constructors done. 4 and 5 done. We can start working on 1, 2, and 3. Actually, I'm going to work on 3 next because 3 is a destructor. Actually, no. I'm not going to do 3. I'm going to start doing this in order because if we'd had the first thing, there's some changes we need to make here too. So the next thing we're going to work on is that static member. So what's a static member? A static member, either a function or a variable, is something that is not associated with an instance of the class, right? Every restaurant has its own name. Every restaurant has its own address. Every restaurant has its own category, right? So I need to create, locations in every single object to hold those things. But there's other things that aren't really associated with an individual restaurant. They might be associated with the idea of restaurants in general, where I want to store something. So, for instance, here we're just going to store the number of restaurants that have been created into the system. Okay, well, that's easy. If I do that, then that number isn't really associated with an individual restaurant, right? Like, how many restaurants are in the system? Well, that number is sort of more tied to the class restaurant itself, not an individual restaurant. In the same way that, like, if I were to ask you your major, that makes sense as a student, right? Because you are an individual student and every student has a different major. If I were to ask you your GPA, that makes sense. Every student has a different GPA. If I were to ask you the number of students at Fresno City College, that doesn't make a lot of sense. One, you probably don't know it because it doesn't make sense for every single student to have to know that. You don't need it, right? Admissions and records, the class that creates student objects at Fresno City College, they should know that information, right? So the number of students on campus is more associated with the class than with any individual student themselves. And certainly there's no reason to store a variable in every single object to store that number. We could take that variable and store it in one location in program memory and just have, you can think of it as either way, have all of the instances share that one thing, or, and there's 2 different ways of thinking about static. One is it's a variable that all of the instances share, true, but not the way I like to think about it. I prefer to think about it is it's associated with the class rather than an instance of the class, right? It's the restaurant in general, the factory that makes these restaurant objects needs to know how many restaurants it's created, or needs to have references to the restaurants it's created, or whatever, rather than every individual restaurant needing to know that. Point being, that's what a static member does. And so here in our .h, we're going to create a static member, and you do that just by putting the keyword static in front of it. And other than that is a completely normal variable. Actually, that's not true. It's C++. It would be normal, except that, remember that thing I did for number ratings? It would make so much sense to be able to do that right here for our static member. Static int, I guess we'll call this num of restaurants. And yeah, I was going to make sure I saw restaurants, right? So static int num of restaurants. It would be so nice if I could do this. So nice, but I can't. C++ won't allow it. You see my red squiggles. C++ would prefer that we do it this way. I have to go to the restaurant implementation file. I'm going to do this right at the very top. Don't know why, I just generally do it there. This is a member of the restaurant class. It is called num of restaurants. and we are going to set that value to keyword. Got a little slow there for a second. Oh, and I also have to say that this is an integer. I do not need to say that it's static. In fact, I believe C++ will not allow me to put the static keyword on there twice. Yeah, it doesn't like it. In the declaration, it was already declared static, so here we're just using the implementation, but weirdly C++ still has you put the type in even though it already knows the type. I find that to be very odd. The whole way you initialize a value for a static member in C++ is odd compared to other languages, but you know, it's kind of an earlier language, so they did stuff in a way that made sense for how they had already written the parsers that kind of go through and grab all the tokens in the language. So there we go. We have this variable, num of restaurants. It'll keep track of all the restaurants as we create them. So we need to actually do that. Here's a constructor. Every time a constructor gets called, we create a restaurant object. So it would make sense that I would just add to this num of restaurants and increment that number. Done. Copy. Paste. Because again, I can't have this one call this version and just send empty string, empty string, empty string. I have to have duplicate functionality, which kind of stinks. There may be a slight way around it in modern C++. I haven't checked, honestly, the 17 or 20 standards to see if there's a way around it, but at this point, I don't believe there's a way of making that easier. But that's where we create our num of restaurants to add to it. Where are we going to decrease the number of restaurants? Well, that's easy. We will decrease the number of restaurants in a destructor. So a destructor looks almost exactly like a constructor, except that it is a member of the restaurant class. Its name is going to be tilde restaurant. Oh, I'm doing the implementation first. There is no reason you can't do that, by the way. I mean, you know, it's your life. You live it the way you want. Just remember that you got to do something. We're going to get little red squiggles because I never declared this. If I want to declare it, copy, go over to the header, paste, semicolon. I mean, the shortcuts I used to go from here to there work the opposite way as well. So now, what is a destructor? Whenever an object is destroyed, right, which just means its memory is being freed, it's deallocated from memory, that object is going to leave memory. If that object has references to other objects, right, you could possibly create a memory leak by not deleting those references. Maybe you just have a variable that you need to update to say, hey, by the way, I have one less restaurant now. I got deleted, so decrease my number, right? That's something would need to be updated. If there's any work you need to do when something is going to be destroyed, you would want to do it in the destructor. Remember, the destructor is not the function that actually deallocates the object. That's the delete function, right? We'll talk about that maybe some other time. But this is sort of like the function that gets called right before delete. This is sort of the, do you have any last requests? Do you have any, you know, personal stuff you need to work on before the end, right? This is your last moments before you get destroyed. And so what we want to do in our last moments, num of restaurants minus minus. Just decrement that number because we're about to go. And done. We've got our destructor, which was number 3. We've got all that. The only thing we haven't done is create a static member function to return the number of restaurants, which is really just a getter. I could probably auto-generate it, but I won't for this one. So here, before I get to sort of the functionality function, how you list these doesn't matter. I'm doing constructors, getters and setters, and then all the sort of unique functions that actually do something that I want it to do. So this is going to return an integer. This is a static function, which means that this is not a function. This is, well, I was going to say it's not a function you should call on an instance of the class, but you can, because there's that other way of thinking about it where all of the instances share this same function, right? But this is not something that is associated with the class, and you can actually, or it's not associated with an instance of the class, you can actually just call it on the class itself. So it is a static function, it returns an int, it's going to be called get num of restaurants. Sure, seems a little long, but I've seen worse. And done. Copy. And bottom of all the getters and setters right here. Paste. All we need to say now is this is a member of the restaurant class. Replace this with some curly braces, and we are good to go. All we're going to do is return num of restaurants. That's it. Oh, and just like up here with our static variable, it was declared static in the declaration, so you don't declare it static here in the implementation. If somebody has a question of why this is, there might actually be a very good reason, but it's going to be a reason that was just generated by somebody in a cubicle someday who, well, it was probably the 1980s, so I guess it was Bjorn Straudstrup, right? But the guy who created C++. He made a decision, right? He just made a decision. This is not like physics where we're trying to discover, laws of nature or the mind of God, right? This is just some guy named Bjorn made a decision. Could have done anything. He decided to do it this way. So anyway, that should now be working. And that means I think we are done. We created a static member variable that holds the number of restaurant profiles have been added to the system, created a static member function to return that number. We implemented a destructor to remove a restaurant. We implemented a custom constructor with 3 strings, which also adds to the number of the count, and then the default constructor, which also adds to the count. This is good. Let's test it. All right, so here we are in main CPP so that we can test our new constructors and functionality. We're going to do, not ready to do that yet. Our restaurant here now works, right? Because we created our default constructor, so that's back to working. Now I want to create a new restaurant. There's a couple different ways we can do this. We can either create a restaurant, we're just going to call it B, sort of the C++ way where we just start sending values. I can actually say restaurant B equals new, or I guess I should say restaurant pointer B then, would create a new restaurant, and then actually just call this function separately and send it different values. So Papalo's Pizza, 369 North, actually they're in the same shopping center, Palm Avenue, and then they are a pizza place, right? So here, restaurant pointer B equals new restaurant, and then I'm actually calling that method sort of explicitly. I'm not going to want to deal with pointers and stuff right now. I'm just going to keep it simple. So we can just do it this way. Restaurant B, and then send 3 strings for the name, address, and category. And remember how I said, see how this just pops up, this little label here? It's really nice when you're calling functions. C-Line does this, a number of other IDEs do this. Whatever you called those parameters, that's what gets put here, which is why it's kind of nice to have the full name of what those things are so that we know what order we're going to do it in. You don't say Papalo's Pizza, and then give the address, because then the address is going to be pizza and the category is going to be the address, right? I can see what the order is supposed to be. It's just helping me out. But our constructor works, so I know default constructor works. I know the new constructor works. Don't need to actually set anything. It's already done. So then b.rate, this is my son's favorite pizza place, so new rating 10. B.rate, let's say I give it a 9. and done. I mean, at this point, we can just do b.display, make sure that's working. And now, maybe last thing, we should do a quick cout, and then just display the num of restaurants. Now remember, if I try to do that, and I say num of restaurants, right, I'm going to get nothing, right? Because num of restaurants doesn't really exist here. I have to associate it with something. I can say a dot num of restaurants, right? Or, well, I'm trying to do two things at once. Let's start with the fact that I don't have access to this. I have to use a getter to get this, right? So it's not going to be num of restaurants. It's going to be get num of restaurants, and that's a function. That's actually going to return what I want. The other side of this is, in addition to having to use the getter, I have to call this on something. Get num of restaurants as a function doesn't exist here. It belongs to something. So I can say a dot get num of restaurants, and that works. This is sort of the all instances share it. And by the way, that is the exact same function that gets called if I do b dot, right? B dot does the exact same thing. But this is telling me I have like it's a clang tidy, basically says like, hey, what you're doing is not exactly like the best way of doing it. Like it works, it's part of the language, you can, but like maybe you shouldn't. And it'll even offer you some stuff. It'll even say, so the problem here is static member access through instance. If I click on this, it switches it automatically to restaurant : : So some of these errors, like CLion is doing a lot to help you. In this case, it wasn't really an error. It was more like, it's kind of not how we talk around here. I don't know, right? Whatever analogy you want to use. To access it through the class, which is the way I would prefer to think about it, restaurant : get num of restaurants. I'm asking the class to give me the number of restaurants, which should be 2. So I'm just going to hit play because I could have had that going the entire time I was talking. And here we go. We've got Eureka Burger with an address. It's a burger place. It's got that rating with 4. Popolo's Pizza, different address, pizza place, 9.5. And there are 2 things here. Now, by the way, I do not... the way that you would delete something would be... There's a couple different ways. One, the way that I created these, restaurant A, restaurant B, these are local variables to the main function. So whenever that function ends, those 2 things get deleted, which is fine, except that we don't see that because they just end. So like I can't call cout get num of restaurants to show you that the destructor is working. What I can do, however, is something a little weird that's not really necessary, but just to show you that it's actually happening. I could also create a separate function, have that function be called in main, and so then when that function leaves, it goes away. But cout, I guess I could say name space is being deleted, and then an end line. OCD&me likes to have spaces around those. All right, so basically I'm just going to, hey, say that I'm being deleted when it happens. It doesn't change much other than it kind of allows us to see that they're being deleted as main gets called, or as main leaves the system, right? So as main is exiting, both of those things get deleted because main is over. If I want something to last longer than a particular function call, although main is obviously a weird function because it's the first one that gets called and the last one that gets dropped off the stack. But like, if I was creating an object in a function and I wanted it to survive longer than the end of that function, then what I would have to do is do that new keyword, the one that I was sort of showing you. So here, restaurant C equals, well, sorry, new returns a pointer. So I need a restaurant pointer C equals new restaurant, and we'll call this, also have to spell stuff right. Restaurant. And so then, out of restaurants. It's weird because it goes so many different restaurants that you figure I would know. Let's say Parma. We're going high class now. The address is going to be, I think it's also on Palm. I'm running out of 456, sure. North Palm Avenue. And capital P, not that that matters. And category is Italian. Very, very nice Italian. All right, so now, this restaurant C that got created exists. In fact, this isn't going to make sense. I have to do this in a slightly different way, don't I? To show this, I'm going to create a quick function. It's not going to return anything. It's going to be called foo, and it's not going to take anything either. Actually, you know what it should return? It should return a restaurant pointer. Otherwise, I'm going to create a memory leak, which is fine for this situation. And so instead of doing this here, cut. I'm going to go down here where I'm going to create my foo. So this is going to return a restaurant pointer. It's going to be called foo. It's going to take nothing because I'm just using it to create this in a separate function. And once I've created it, I should just, actually, I don't even need to give it a name. I can just say return, right? The new keyword, well, here, I'm going to not be slick. Return C. All right, so this function, this object gets created in a new function, right? When this function ends, normally those objects are deleted, but this one was created using the new keyword, so it was stored in the free store, the heap. Technically, you don't need to know any of this to do the assignment, by the way. I'm just pointing this out. And so it's not going to get deleted once this function ends. It's going to live on and still exist over here. So I could say something like restaurant pointer C equals foo. So foo is going to return that restaurant pointer for that restaurant that was created over there. Yeah, if I don't delete, specifically delete that restaurant object, it will continue to live on. So here, let's copy, paste. I think I hit copy when I wanted to paste. Copy, paste. So then we create that. Then I'm going to delete C, and then, oh wait, hold on. Paste. There we go. Now I'm actually testing stuff, right? So we've created two restaurants just like we had. So when we do this, we're going to get two. I use this function to create a new restaurant, which goes over here, but it survives, right? Comes back, print out the number of restaurants. We should see 3. I delete C, we should see 2 now. And then, yeah, we'll see. Hopefully this actually works to kind of look at what it's doing. There we go. The other thing to note is, so Parma was deleted. Parma was deleted here in this function, but the object continued to live on. In fact, if I were to get rid of this line, be interesting to see what happens. Yeah, 2, 3, 3, because I got rid of the delete, right? So I didn't do anything in between those two calls. Popolo's Pizza is being deleted. Eureka's Burger is being deleted. I never deleted Parma. Parma effectively got deleted when my entire program was removed out of memory. But like I had a memory leak because I never deleted it, right? In fact, if I were to call foo, throw away the return value, like I don't care, I'm just using this to create stuff. Actually, I guess I could do that, but I don't want to. Right? Now we're to run this. I'm creating a whole bunch of objects with these foos, these calls to foo, that all now exist in the free store, like in the heap, but I don't have references to any of them. I can't access any of those restaurants I created. That's what we call a memory leak. You're using more memory than is necessary for your program to operate because you just didn't delete something. Memory leaks can cause video games to run slow, something you might be familiar with, because you're using a ton of memory, and video games are already system intensive and using a ton of memory. So the last thing you want to do is waste the memory you have. Anyway, these are at the very end here, just some advanced topics, things to think about as you're going through the reading and stuff, and thinking about creating stuff. When you create something locally, it gets deleted when you exit that function, but if you're creating it manually using the new keyword, it's going to survive in the store, the free store, until you delete it purposefully. So yeah, don't use the new keyword unless you know what you're doing. Although there are some times where this is actually the correct way. This is the way you want to do it. For anything you want to survive past a single function call, that's a good call. All right. That being said, that is the first 2 stages of your project. Hopefully you found this helpful. Hopefully you didn't find it too confusing towards the end. And yeah, we'll see you online.